So, we started? Okay. Now, problem 1 is a very massive problem. We're first going to consider a sequence of elementary reactions, which is a proposed mechanism. So before I start talking about something being a proposed mechanism, what is it, what makes a mechanism acceptable in terms of a proposed mechanism? What makes a mechanism an acceptable mechanism as far as
when it can accurately predict an outcome?
When it predicts what kind of outcome? The one that is
Experimentally
yeah.
seen.
So we all, with all kinetics, you start with the observed rate law. And you take the observed rate law and then you try to come up with a sequence of elementary processes that gives the exact same rate law. So that way, so in the wording of this problem, I say the following sequence of elementary reactions represents a proposed mechanism for a reaction. So that inevitably means it's going to give me the same rate law as the observed reaction. That's the ultimate criteria. We're always based on the law, and the law is what happens in the lab. It's what we observe. It's irrefutable. You can't argue with results. And so you can dispute interpretations. And no mechanism can be proved. It can only be consistent, and it can only be disproved. This is always a continuous work in progress. Nothing is etched in stone. Okay, now, the first step was the first step involves the process, this compound interacting with some compound M, and in fact, in an equilibrium step with this particular species, which is the compound with the M inserted between the compound and the X bond. And then the second step is this particular compound is formed that particular compound going directly to break up to in a decomposition. And delta G2 double dagger is equal to 20 kilojoules per mole. So now, the second step is decomposition of this to give AB3 and M plus X. And then the last step in the sequence is the AB3 so formed interacting with Y. Giving me a product. And delta G double dagger 3 is equal to 10 kilojoules. Okay, now we're going to be discussing all the features of this. While it's up there, you'll notice I didn't have anything about fast or slow. Okay. So, what can we tell about this? I have the provided information where I give you delta G double dagger. Which is the fastest step? So I want to ask, which is the fastest step in this particular process?
Step 3.
Step 3. Why?
Because it needs less energy for it to happen.
It has the lowest energy of activation. Yeah, you're absolutely right. Does everybody see that? And which is the slowest step? Step 2, for that same reason. And which one's the middlest step? Yeah, step 1. Okay, yeah, but that, so we gain some insight as to if this information is provided, we can tell which is the fast step, which is the slow step, and no reaction when it comes time to observe can happen any faster than what? Yeah, yeah. So this is the key. And then what do we call that step?
Rate determination?
Yeah. Because inevitably that's what we measure experimentally in the lab. The slowest step in the process. And that's the one with the highest energy of activation. So, now, the first question, A, is I want to write the overall reaction. And we'll talk about what are, in other words, let's talk about a few things right now. Do you see, well, like for example, what's this compound? What do we call that?
Intermediate.
That's an intermediate. What is the characteristic of an intermediate?
Produced on one side and consumed on another.
It's produced in one step, consumed in another step. But it's not something that is introduced by us in the experiment. Okay? So, yeah, this is an intermediate. Are there any other intermediates?
A.
So this is an intermediate.
Yes,
Okay. What about M?
that's a
Catalyst.
Why is it a catalyst?
because it's a,
It's consumed first.
It's in the reactants and the process.
Yeah, it's consumed and then produced. Intermediates are produced and then consumed. So this is actually introduced, so we have control over that. That's in the, that it comes in, is consumed in an early step, and then later is produced either in the same or in a subsequent step. So it's a catalyst. It emerges from the process in the same way it went in. And so that's a catalyst. So I have these two, this is an intermediate, this is an intermediate, this is a catalyst. What's Y?
That's
Gone.
The one replacing X?
Well, if it's not an intermediate,
Part of the overall reaction.
it's part of the overall reaction. It occurs on what side of the arrow? On the left side of the arrow, we have things we call reactants. And on the right-hand side of the arrow are products. So what's Y?
Reaction.
A reactant. Okay. Okay. And that would make this a product. Okay. And what's X? A product. Okay? Good. Now we've described everything, and now I want to write the overall reaction. Well, this drops out. This is produced and consumed. And everything that remains is the reaction. So I have the reaction being AB3X plus Y. I write the catalyst over the arrow.
We're gonna count off if we don't.
And that's the first question, A. So you have to write the overall reaction. Everybody got that? Now B, part B is, what are the intermediates?
AB three and AB.
Okay, so we've answered the first two problems.